Alright, so we have this question. By the way I'll be doing this is in 40 minutes, trying to understand the question the first 15 minutes, and then if I can't, then obviously trying to figure out the solution, and then eventually trying to understand the solution. So no time is wasted and the concepts are covered. So assign cookies. Assume that you are an awesome parent and want to give your child some cookies, but you should give each child at most one cookie. Each child I has a greed factor, that is g of I, which is the minimum size of the cookie that the child will be content with, satisfied with. Each cookie j has a size sj. If sj is greater than gi, we can assign cookie j to the child I, and if the child I will be content. Your goal is to maximize the number of content children and output the maximum number. So if input is g and this is the s, and g is a greed factor, and what's s? I don't know what s is, but you have 3 children and 2 cookies. Alright, so I guess that's the has a size of sj. Alright, so 2 cookies. Alright, size of 1. The greed factor of 3 children are 1 to 3, and even though you have 2 cookies, since their size is both 1, you could only make the child whose greed factor is 1 content. Alright, so 3 children, 2 cookies, the size of both the cookies is 1, but the greed factor of 1 is 1, 2 is second child is having the greed factor as 2, and then the third one is having it as 3. So I can only satisfy 1 because obviously. So the child whose greed factor is 1 is content. Yep. Alright. G is 1 2 and S is 1 2 3. So you have 2 children and 3 cookies. The greed factor of 2 children are 1 2, and you have 3 cookies. The size are big enough to gratify all the children. You need to output 2. So how many children satisfied right here? 1. How many children satisfied right here? 2, because obviously. Yep. Alright, so so it's like one child can have that one cookie only, then the next one will be having another, so the next one can't be fulfilled. So yep, the topics for this question: array to pointer, greedy sorting. Alright, so okay, so our approach can be like the brute force approach can be to start the question, and when we will start the question, what we can do is that we have 2 arrays g and s. We see if the value of g matches the value of s. I have an int count that will be plus plus, so value of count increases. So like, let's write our thoughts in the form of code. If I is 0 and I less than g dot length I plus plus, and then for int j equals 0, j less than s dot length j plus plus. So what we can do is that alright, let's do one thing. Let's keep j as I. Yep. So because if I is 0, it will be focusing on the 0th element. Let's try to not think much. Let's try to code more. So I have 2 for loops. What is the it's O(n) square. It's gonna be O(n) square. It's fine. We'll try to find out an optimized solution afterwards. So what we can see is that we have 2 for loops, one for the g and one for the s. And then what we can do is that if int answer equals 0, if So if g no no g yeah g I is equal s j answer plus plus, yep, and then at the end we can return answer. Obviously works for case 2, but yep, doesn't work for case 1. The error, okay, so I is 0, j is I, so both are at 0. So when we are talking about one of g, we are talking about one of s, and then it goes again. So it's like, yeah, it's gonna be giving an output as 2. Yep, output is gonna be 2. I don't want that. Yep, because it's like j comes at I and then it goes ahead. Yeah, I don't want to go ahead, I just wanted to talk about that element only. How do I do that? How do I make sure that j only runs for that particular element and not the rest of them? How about now? Oh, okay. I don't think so the code is gonna work, but let's see. Yep, not many test cases passed because it's breaking. So it's like if s value of s is 3, so 1 can be satisfied, yeah, or g of I is greater than s of j. How about that? My goodness, I should have used this test case. Wrong answer. Use this test case. How about that? Wrong answer. Okay. Output is coming out to be 0. If g of I, wait, how about now? Yep. Obviously they'll have a test case that is gonna go and go, obviously, and then it's gonna give out the wrong answer. Yeah. Output is 201, expected is 206. Damn. So does that mean that I need a more optimized solution for it? Like, there has to be something. Because see, the thing is, like, if the output is, see, now if they are, alright, so for this test case, basically, there has to be some sort of test case because it's only 19th out of 25. I'm pretty sure that the test case is ahead because it stops at the test case where it is not having the correct answer, so it's like I still haven't seen the 20th test case or 21st, 22nd, 23rd, and 25th. So the thing is, like, this test case will be extended in the further test cases. So the thing is, at the end of the day, I'll be needing a solution that is more optimized. So okay, how do I use sorting right here? Because the arrays are sorted, I guess. Are they? Ooh, they're not. Let's do one thing. S dot no arrays dot sort s. Yep. Alright, how about now? Let's check for these 3 test cases, and then yeah, it's working. Use this test case. How about now? Time limit exceeded, obviously. Oh, it's working, that's nice. Yep, as I told. Output is 73, expected 70. So another issue is that I'm so close to the answer. Yeah, I'm so close to the answer because it's like output is 73, expected 70, and blah blah blah. The point is that the number of elements in the array, it's like it's practically difficult for me to figure out where the error is coming. So let's do one thing. We tried sorting, we had the 2 for loops and everything. Let's try to have this and then try to figure out the error. Code runs well for 22 25 test cases, but faces issues with the other. So how can I optimize or improve my code? The approach is close, but it can be optimized for efficiency and correctness. There are some key features problems with the code nested loops cause inefficiency of using nested loops. This can be optimized to n log n. Okay, not fully utilized. I don't have to utilize that. You should use a 2-pointer approach instead of fixing one I and starting j from I unnecessary sorting separately. Sorting is correct, but the way loops iterated could be improved. So it's like 2-pointer is like a greedy or something. Like 2-pointer and greedy are like the same umbrella or something. Like sort both g children, and I did that. 2 pointers I and j for s. Alright, so greedily the smallest. What's the code? So this part is done by me. Int I and j 0. Alright, and answer 0, and answer is given 0. You have a while loop, obviously. The time I is less than that and g is less than that. If this is the case, answer plus I. So this is what, greedy algorithm or something? Greedy strategy. Return answer. If you see sj is the number of cookies, if that they're greater than or equal to g of I, that's what I have done, but yeah, in separate ways. Answer plus. Alright, so I plus. Move to the next side. Alright, it's a 2-pointer approach, fair enough. I haven't utilized the 2-pointer approach in the right manner, so yeah. Okay. Alright, so I guess what else it has to offer. Alright, so I understood the code, by the way. So we can have int I as this, and then in the same manner we can have int j as this. Okay. We can remove this statement completely. We can have this if copied. We can remove these for loops. We can add a while loop wherein while I is less than g dot length and j is less than s dot length, what we have to do, we're gonna have that if, but instead what I can do is less than or equal to. I can remove this, have answer plus, and then I plus, and then j plus, and then I can return the answer. Okay, my bad. What? Can't find the symbol g dot length. You can't find g. Oh, My bad, spelling error. Okay. Alright, the code works. Alright, the code is optimized. Yep. So the learning we took from this is the correct usage of 2 pointers basically. So I is 0 and j is initialized as 0. So while the time like I is less than the length of the number of children and j is less than the number of cookies, the loop will run, and the moment it becomes equal, that means it's index out of 1 or something, so it's gonna exit. So while all that is happening, if g of I, that is number of children, are equal to or less than the cookies, we'll have to have answer plus plus. Yep, we'll have to have answer as value increased, and then we can move I ahead. So it's like it's gonna compare, like if g is 1 and if s is 1, answer plus plus. Now I moves ahead. Alright, loop exits, j moves ahead. J becomes 1 and I becomes this. Are these equal? Like, is nope. So alright, so I need to just understand one thing. What if control x, control v, how about this? I know we can't do this, but I'm just like trying to figure out why. Time limit exceeded or something. Yeah, okay, I understood that. Fair enough. Wait. What if move to the next cookie, move to the next child? What if I keep j plus plus inside of the if condition? If you move j plus plus inside of the if condition, the code might not work correctly. Here's why. The j plus plus always if ensures that if we always check the next cookie, even if the current one was too small for the child. This way we don't get stuck at trying. What happens if you move j plus plus inside if s is too small for gi, the loop will not increment j plus plus, and the same cookie will be checked repeatedly. If j is too small, as it is here in this case, 1, and it's like, and the same cookie will be checked. It's too small for gi. Yeah, it is. The loop will not increment j because obviously, yep. Yeah, understood. If it's like g is less than that, but here in this case g is greater than that, so it won't be going to the next cookie. Obviously, I understood. Alright, so question done. This was quick. So yep, until next time.